So this is what's on my workbench at the moment. Got a few knives here, partially assembled, waiting for heat treatment in the furnace. So, got a couple of daggers, approximately styled like a World War II Fairbairn Sykes Commando dagger, but possibly a bit larger. I'm going to have a nice handle on it made out of different sorts of wood layered together, but I've also learnt to tape over the handles when I'm dealing with oil and glue and stuff so the wood doesn't get messed up. The way these fellas are assembled is there is a pommel that is attached on with a cross pin. Remove the cross pin, that fella comes off. Handle is a piece of wood that has had a rectangular hole bored through it. Guard and actual blade. Only the actual blade is going to be heat treated today. Everything else waits here till it's done. So I have a couple of daggers like this, and I also have a more conventional field knife, once again with a cross pin pommel style of attachment on it. Let's get this bit of wire out like that. Honestly really tricky to drill out that shape, but anyway. Blade tang, guard goes on like this. Handle is a piece of wood with a hole bored through like that. The whole space between the handle and the tang will be filled with glue once it's all done, but since the blades haven't been heat treated yet, they are just all loosely held together like this for the sake of preparing the handle pieces. Got my furnace thermometer here ready to go. Has a probe that will go into the furnace like so, for the sake of checking that my blades are actually at the correct temperature when it's time to do the quench on them. Temperature's going up, but we need to get this whole affair up to about 800 degrees to do heat treatments on high carbon steel. Time to wind the gas pressure back a bit. And get this thing steady at about 850. I know that a lot of people say that you can, quench blades with canola oil or motor oil or whatever, and, I've done that in the past, but now I'm starting to think that if you're going to go to all the trouble to quench some steel that you've bought and put hours of work into, why not just buy the proper oil? So, here is a container of actual industrial quench oil. Let's put the oil warmer into it. The oil warmer is just a lump of metal off a train that is used to warm the oil up slightly. Oil is meant to be slightly warmer than room temperature before you actually use it to quench stuff. So, there's the oil warmer. Do a normalizing cycle on steel, which means heat it up to something near the quench temperature and then let it air cool for a bit. So this is my air cooling rack. Before each blade actually gets quenched, take them out of the heat, go and put them on the normalizing rack for a little while. tent arrangement in the middle of my furnace. It's just a bit of square hollow section with some pieces of wire poked through it, and the whole idea of that is partly to even out the heat a bit so that the flame isn't going right onto one blade and making a hot spot that's a different temperature to the rest of the thing, and partly to give me a sort of a little rack that keeps blades upright while they're being heated. It also holds the little temperature probe pretty close to where Alright, here's the fun part that everyone loves. It didn't go clean, that's always good. One didn't go clean either. One of the reasons we prefer to use oil for this is that oil doesn't cool things quite as fast as water. Cooling things in water can sometimes cool them so fast that they shatter and crack. This looks good. I've also rounded off the edges of all these blades with some like 120 grit sandpaper, so that there aren't any sharp points around them. Because trying to quench sharp edges can also create a place on your workpiece where it will start to crack, and that's not something you want to have happen after you've done this much work on them. Also going to heat treat and off cut the same way that I've done with every other part, just so that I can break it later and see how tough the blades are. I'm working on the premise that if I heat treat this off cut the same as everything else, it will give me an idea of how tough these blades are going to be. At this stage of the process, the blades are fairly brittle like glass. If I dropped one of these, it would probably just shatter. So I'm going to clean the oil off a little bit, load them into a padded container and take them inside for their tempering cycle. One of these daggers has warped a little bit, but that's something we can fix later on. Definitely not something we try to fix now. If I tried to correct that slight warp now, it would probably crack in half. Still, if I run my finger along the edge of these, I do not feel any cracks forming, nor did I hear any of them go ping, so the heat treatment process has probably worked successfully. People say that you should cool certain blades below zero before you do the temper cycle, and some people actually use cryogenic stuff like liquid nitrogen and that. I don't know. I have got a pipe full of refrigerated sub-zero methylated spirits. I'm just going to soak all of my blades in that stuff for an hour or so. I don't know if it's actually necessary for non-stainless, but hey, I will shove the ice cream aside for a while and give it a try. It's never hurt. Knives are now out of the fridge. I've let them warm up to room temperature before putting them in the oven. This is the temper cycle. Put them in the oven at like 230, 240 odd. And give it, I don't know, 90 minutes perhaps. Okay. Slight bronzy yellow colour, looking good. Right, let all of that cool down, but that's the colour we're expecting. If a knife is going to break, a common place that it will break is this joint between the tang and the blade. Something that you can do to make knives a bit tougher is to reheat the tang with the gas torch. To soften it a bit and make it less likely to snap. So what I tend to do is reheat the tang until the patina colour goes blue. Let's push this colour change along here. This undoes the heat treatment to a small extent in the area most likely to fracture, making the knife as a whole a bit tougher and less likely to break. It's ready to be polished. So I've got this vise that I made myself, attaches onto the anvil. Attach that little follower in there, like so. And I've got a block of sandpaper wrapped around a cork block, and I've got some podcasts to listen to because this is a really boring and time-consuming part of the process. Anyway.
A few moments later.
One side done at 120 grit. Flip it over. Under the supporting wood. Other side. Okay, I have gone over this blade with several different grades of sandpaper. I've also used some buffing compound on a rag wrapped around a cork block, and also the buffing wheel, and now we have a polished blade. Really difficult to get the polish exactly right on these things, but I try my best. What can you do? Alright, got the handle parts glued on for this pair of knives. Let's take the tape off and see how it's looking. If I can actually get the tape off. Fuck. I tend to tape everything up while I'm gluing handle parts on, because glue has a tendency to run everywhere and I don't want to get glue on something that I've spent ages polishing. Aha, and there you go. So shiny that you can see the reflection of me and the GoPro. There's really something about holding a knife that was exactly designed to fit your own hand. Excellent. Not actually sharp yet. I always keep these things somewhat less than 1 millimeter blunt on the cutting edge so that the heat treatment process doesn't crack them up. And the other knife, the one that was made out of a horseshoe rasp, the wood on the handle here came from a camellia tree in my parents' place back in Queensland. So, and the wood on this other knife came from a tree owned by my wife's family, so both of them have got a bit of sentimental value in the handle materials. So, white camellia wood handle. And there we go. How good is that? A few little bits of tape around the... Right, so now that the knives have their handles assembled, it's time to sharpen them. This whole affair here is a homemade sharpening jig that I've come up with, which I pretty much knocked off a smaller, less useful version that I saw. So there is a clamp here that is used to clamp the knife in place. One of the good things about doing blacksmithing is that I can make myself a wrench to fit any particular size thing that I want. Sharpening stones go on what I call a stone carrier here. This little bobble at the right has a piece of threaded rod on it so I can adjust the angle, and this whole affair keeps the angle of the sharpening stone to the blade constant while I go like this. Putting an entirely new edge onto a new knife honestly takes a while, so I'm just going to do this and then turn the camera off and then come back later once the thing is actually sharp. Okay, once I've sharpened all the way along one side, I can undo that. The entire purpose of this clamp is that I can flip a knife over, sharpen the opposite side bevel, and keep the angle the same both times. Tighten that fella up. Seems like a bit of stuffing around, but it always gives me a nice, neat sharpening job when I'm sharpening a knife up for the first time. both sides and the grinding bevels sort of meet at a point, it will form a thing called a burr. A burr is a tiny little scratchy bit of metal that you can feel with your fingernails. Can you hear this? If there is a tiny folded scratchy sensation on the opposite side from where I've been grinding, that means the two grind bevels have met and actually formed an edge. Now it's time to smooth that burred edge off until we get a nice smooth cutting edge. At this point I'll get my stone carrier, unlock the stone, flip it over to a smoother grit of stone, and flip the knife carrier over. And now we repeat this process for finer grades of sharpening stone. Okay, the final step in the sharpening process is to give the newly sharpened blade a few wipes on a razor strop, a piece of leather that has had a bit of buffing compound or similar applied to it. There we go. To put that final bit of bite on the edge. So, yeah, drag that file on there. This way a bit. Wipe the compound off a bit. Now, how are we going with this thing? Not too bad. Right, so this stuff is called Kydex. Kydex is a sort of plastic that's ideal for moulding. You can press it onto things, heat it up with a heat gun, and it will form fit onto the shape. And once you've done that, you use these little rivet fillers to construct two halves of a knife sheath. So here is the knife that we are working on, just living in a cardboard sheath until I get the Kydex done. And put it there and pretty much trace around it. I've just covered this Kydex with some masking tape that I can draw on to work out the shape. Once I've got a couple of pieces cut up and ready, we will mould them with the heat gun to fit around the knife. Good. I've marked out the drill holes that I want on this double back bit of Kydex using masking tape. Let's drill some holes. So, this is what I want a finished Kydex knife sheath to look like. I should probably have filmed a few more steps in this, but anyway. What I've done here is I have moulded the sheath around the crossguard so that the entire affair can be shaken upside down and it won't fall out. To draw it, I simply push my thumb here. Yep. Now the knife can be removed. And when I push it back in, that is an excellent Kydex knife sheath, if I do say so myself. Well, I've had a bit of a stuff up. Both of the daggers that I tried to make came out of the fire kind of warped. Can you see that? Sort of not exactly straight on like that. So I tried to put one in a vise and straighten it a bit, and it snapped completely. I don't
I don't even know where the far end there has actually gone. It's probably embedded in the wall over the far side. So I'm going to have to remake this one from scratch, and I'm going to have to find some way of heat treating these things that doesn't warp them to quite the same extent. But anyway, not letting this tragedy go to waste, what I have been doing is getting a sample of the same steel that I used to make these, just a little offcut, and I was going to break it anyway, just as an example of how strong this steel plus heat treatment cycle is. So, since I can't really grind this down to make anything else out of it, I reckon we'll put this in a vise and break it and see how flexible the stuff is. Okay, I'm not sure exactly how well this is going to work, but we'll give it a try. So, we got a device, got a protractor, this is the test sample, we'll put it in the vise, line the whole affair up so that's more or less straight, get a big bit of pipe, like that. Wearing eye protection because this is absolutely going to go spraying at some point, and let's see when it breaks. Shit, the box is going. Wow, okay. So, grain inside is fairly fine, so the heat treatment definitely went through the whole thing, but they really shouldn't be breaking that soon. Also, if creaking annihilated, it's my protractor. Probably the same one I have in school. Okay, so what this really means is I should probably up the heat treatment temperature and soften the whole silly thing a bit. Okay, remains of broken blade. Let's pretend I've stabbed a dagger into something. Shit, that entire thing is moved. Okay, really, if I was heat treating things correctly, these things should bend a fair ways and bend rather than break. So, probably need to adjust my heat treatment cycle a bit. Anyway, round 2. Huh. See, that's probably what we want, really. If the blade was stuck in something and it bent permanently like that, that is at least repairable. It's much better to have something slightly bent than have it go sprawling and shatter completely like the last piece. Interesting outcome. Right, so I'm going to get a piece of 1084 high carbon steel. I'm going to put masking tape on it, and I'm going to trace around the approximate shape that I need, like so, and then I'll cut that out on the bandsaw. Okay, I have cut out a new steel blade blank, and I've made sure that it fits onto the existing handle and pommel that I already had made up. Pommel locks box in with this sideways pin. And there we are. So, next thing to do is to fit it onto my angle guide grinding jig and get it onto the grinder to have some bevels ground in. Now, once I've ground the bevels in on this using the grinding machine, I've often found it's really tricky to get the transitions lined up exactly the same either side. So what I've done is I've made up this sort of a little clamp, which I'm going to attach in the vise like that. And by filing these fellows here, and on the other side, get the bases lined up exactly the same either side of the blade there. Now, I've mentioned that we've had problems in the past where I've taken fairly thin blades out of the fire, I've done the oil quench, and then they've come out slightly warped, and when I try to straighten them later on, they snap. So what I'm thinking to do about this next time is use a couple of paired aluminium plates in the jaws of a vise to try and hold the thing straight while it's cooling down. Once a blade comes out of the quenching oil, still got a couple of 100 degrees left in it. What I'm thinking is we take it out of the fire, we quench it in the oil, then we put it between a couple of aluminium plates and clamp it like that while it loses the last couple of 100 degrees of its temperature. Maybe that'll keep it straight. I don't know. We'll give it a try. Right, so increasing the temperature that you temper the blades at should, in theory, make them more resilient to breakage. So, under this, I'm going to put them up to 240 odd. Let's see how that goes. Now that the new blades are definitely straight, comes the really boring part. Hand sanding. Got my cork block with some sandpaper wrapped around it. Whole affair is secured to an anvil. So, one side done, flip it over to the other side. go. Pommel glue up underway. How good is that? Okay, a little bit of tape still stuck on there, but still, I am reasonably happy with that. Use some acetone to clear off some tape marks. Finally, at the moment that I've been waiting for several months, ever since I accidentally broke its predecessor. That is a reasonable looking dagger. Alright, it's been several months since the start of this video, but every knife project on my workbench is now completely finished. We got the twin daggers with the handles made of camellia and red gum interspersed like that. We got the field knife with a handle made out of red gum, made out of carbon steel. And we've also got the other field knife with a handle made out of camellia wood from a tree at the house where I grew up, and the blade made out of a rasp file. And that's all done. Thank you all for sticking with the video for this long.
Oh, my package is here.